Hello and welcome. I'm Stefan and today we'll talk about coordinates, points and lines. Now about the distance between 2 points. When you choose an origin, draw an x-axis to the right of the page and y-axis up the page and choose scales along the axis. So now you have set it up a coordinate system. The coordinates of these systems are called Cartesian coordinates after the French mathematician René Descartes, who lived in the 17th century. Okay, now that we've set up our coordinate system, we'll find 2 points, A and B, and they have coordinates. We'll see for A, it's 4 on the x-axis and 3 on the y-axis, so we'll write that down, like that, yeah. And for the point B, we'll find that its x-coordinate is 10 and y-coordinate is 7. So we can point it out, okay. And that's point B. It's 10 and 7. Okay, the part of the line AB which lies between A and B is called the line segment. The length of the line segment is distance between the points. We can also write down points A and B like this, just to be sure which coordinates is which. A third point, C, has been added to this coordinate system, so it will form a right-angled triangle. You can see that the C has the same x-coordinate as B and the same y-coordinate as A. That is, C has the coordinates of 10 and 3. Now, if we remember the Pythagoras theorem, where we know that the square of C equals square of A plus square of B, we can use that to determine the length of our segment. It is easy to see that the AC has the length of 10 minus 4 equals 6, which is the difference between the x-coordinates and CB has the length of 7 minus 3 equals 4, which are y-coordinates. So, using Pythagoras theorem in triangle ABC shows that the length of the line segment AB is 10 minus 4 square of that plus 7 minus 3 square of that. It all goes under the square root because we know how Pythagoras theorem works. So we'll calculate that. Square of 6 plus square of 4 equals 36 plus 16 equals square root of 52. Square root of 52 is approximately around 7.21. The idea of the coordinate geometry is to use algebra so that you can do calculations like this when A and B are any points, not just the particular points like we had. It often helps you to use a notation which shows at a glance which point of coordinate refers to. One way of doing this is with suffixes, calling the coordinates of the first point x1 and y1 and the coordinates of the second point x2 and y2. For example, x1 stands for the x-coordinate of the first point. Now what we have here is that point A is represented with an x1 and y1, and for x2 and y2 we'll have point B. x2, y2. Draw a line to connect. So now we add point C. Its coordinates will be x2 and y1. x2, y1. We can show now that the length of the AC is x2 minus x1, and the length between C and B is epsilon2 minus epsilon1. So we can use Pythagoras theorem and we can show that the length of the AB is x2 minus x1, square of that, plus y2 minus y1, square of that. It all goes under the root. An advantage of using algebra is that this formula works whether the shape and position of the triangle. Coordinates can be negative and positive. So if coordinates of the A are negative, the line slopes downhill rather than uphill as you move from left to right. We can find ourselves the length of the AB in both of those cases. Now we'll find points A and B. So the point A has the coordinates of minus 2 and minus 1. Minus 2, minus 1. Okay. And for the point B, we have number 3, number 5. That's point B. We'll write down 3 and 5. We can connect points A and B. Okay. So, point A, minus 2, minus 1. Point B, 3 and 5. So the lengths are x2 minus x1, which are 3 minus minus 2 equals 3 plus 2 is 5. And for y2 minus y1 equals 5 minus minus 1, which is 5 plus 1 equals 6. Those are our lengths. From that we can find that the length of AB is 3 minus minus 2, it all goes to square, plus 5 minus minus 2, we square that also, and put it under the square root. That is square root of square of 5 plus square of 6 equals square root of 25 plus 36 equals square root of 61. Okay, now for the second example, we'll find ourselves point A with coordinates 1 and 5. That is 1, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5. And for point B, it will be 6 and 2. Point B, 6, 2. We connect those lines to form line AB. So we have x2 minus x1 to determine the length, which is 6 minus 1 equals 5, and y2 minus y1 equals, we have 2 minus 5 equals minus 3. So the length of our BA, which is the same as AB, will be x2 minus x1 square of that, so 6 minus 1 plus y1 minus equal square of that and square root. So to calculate, we have 6 minus 1 equals 5, square of that. 2 minus 5 equals minus 3, square of that. So we have 25 plus 9 equals square root of 34. So we know that the AB is the same as the BA. We can come to our final conclusion that the distance between the points A and B, which have coordinates x1 and y1 and x2 and y2, or the length of the line segment joining them, is x2 minus x1, square of that, plus y2 minus y1, square of that, and it all goes under the square root.